Alright, I'm not having much luck with the microphone because I just tried again and I just recorded a 5-minute video this time. At least it was only 5 and the microphone was off, so hooray. Let's do this again. Direct variation. Another term you might come across in questions is directly proportional to. That also means direct variation. Direct variation is a term we use whenever we have a formula that looks like y equals kx. Now you know y and you know x, but k is something we call the constant, k for constant obviously, of proportionality. Yeah, I can't write. The constant of proportionality. So for example, if I'm buying, train tickets for $10 each, then how much I'm going to pay is 10 times the number that I sell. So if I sell 1, I'm going to pay $10. If I sell 2, I'm going to pay $20. If I sell 8, I'm going to pay $80. Congratulations. So the P, so how much I pay, is going up proportionally with the N. It's going up like directly with it. So that's what we call direct variation. So we get questions that look like this. Garden mulch is sold in bulk with the cost, C, proportional to the volume that you buy. So it's obviously going to be a certain amount of money per litre, or cubic metre, sorry. So for example, if we were doing example question A, as soon as they say the word proportional, I'm going to highlight this, as soon as you see the word proportional, you can assume direct, and you can write down something along the lines of y equals kx, but it's better to use the variables that they give, so the cost equals k times the volume. So that's it, that's written down algebraically. Let's have a look at question B. K we don't know yet, but B is going to help us out. They've told us that the shop quotes $270 for 7.5 metres cubed. So we know the cost is $270. We don't know K, but we do know that it's for 7.5 metres cubed. We can find K really easily. We just divide by 7.5. And you've got a calculator, you can tell me this. 270 divided by 7.5, 36. And if you were thinking about this actual problem, this means it costs $36 per metre cubed. So for example, if I'm going to chuck this back in my formula, C equals kV, well I know K is 36, so C equals 36V. So if I buy 1 metre cubed, 36 times 1 is, well, $36. If I buy 2 metres cubed, 36 times 2 is $72. So it makes sense. If we were going to sketch this, we don't do a great job of it. It's not worth the time. We do a fairly rough axis. We think, well, what's it cost for 0? Oh, this is C and this is V. What does it cost for 0 metres cubed? Well, it costs nothing, so I'm going to pass through the origin. And all of these do, by the way, you always start at 0, 0 if it's directly proportional. And what does it cost? Then I just draw like a straight line. And here I might just, I'm cheating massively, but it's fine, you'll do this. So this might be 7.5, and this would be 270. So, obviously I didn't measure that out, I just generically decided, and you will do that. 7.5, 270. And that's all the information you need for something like this. Question C says, how much does 12 metres cubed cost? I'll zoom in for you. How much does 12 metres cubed cost? Well, that's V is 12 because metres cubed is volume. So C equals 36 times 12. The 36 doesn't change for this question as soon as you find it, and you'll usually find it at the start of these questions. You'll use it again, 36 times 12. So C equals $600. And finally, D. If you do a good enough graph, you can use your graph for those, but I honestly wouldn't. My graphs are never good enough. How much can I buy? Oh, no, it's not $600. 36 times 12. Oh, don't tell me I've actually got to figure this out. 36 times 12, $432. How much can I buy for $600? 600 equals 36V. Divide both sides by 36. I want to know the volume. And I get 16.67 equals V. You won't get marked down for that, but you might want to do 16 2/3 meters cubed is the volume. That's it. I'll go have a look at the actual question that you're going to do.